हेलो। हेलो।
Yes, sir. You are audible.
आई एम ऑडिबल ना?
Yes, sir. Very clearly.
Audible, sir.
गुड गुड प्रियांश, हाउ आर यू?
Fine,
Sir,
sir.
I'm fine.
गुड गुड। सो
कैसे हैं सर
टुडे
आप?
बस बढ़िया यार, बढ़िया यार। आप लोगों के लिए भी कुछ ना कुछ करता रहता हूँ। नहीं, अभी तो ये कम्युनिटी बना दी है। अभी जो परमानेंट मेंबर है उनको एवरी टाइम दे कैन ज्वाइन फ्री फॉर 1 ईयर। ठीक है, तो ये फैसिलिटी।
Okay.
Okay.
11:45 का टाइम दिया है। और भाई रिजवान,
हाँ सर, कैसे हैं?
बढ़िया बढ़िया। कहाँ अभी? आउट ऑफ इंडिया हो गया?
हाँ सर, मस्कत में ही हो, आउट ऑफ इंडिया।
अच्छा, मस्कट। गुड गुड गुड।
हाँ सर।
कितना टाइम हो गया?
सर ज़्यादा टाइम नहीं हुआ, अभी 4-5 महीने हुए।
ये मदन सिंह हैंड रेज किया, क्या है भाई? कहाँ है मदन सिंह? रेज हैंड। तो बढ़िया चल रहा है यार। वहाँ जाना तो बड़ा मुश्किल रहता है, मैंने देखा है यार। बहुत परेशान मतलब कर देते हैं लोगों को, नहीं?
नहीं नहीं सर, ऐसा कुछ नहीं है, वो आपने एक मूवी देखी होगी इसलिए आपको ऐसा लगा है।
नहीं, मूवी
जो
से
साउथ
नहीं।
की।
मैं तो खुद ऑफर है ना, मेरे पास वीजा आया हुआ है सऊदी अरेबिया का।
अच्छा अच्छा अच्छा।
हाँ, वो तो आया था, लेकिन वो थोड़ा सा।
प्रोसेस बहुत ज़्यादा है, प्रोसेस है, प्रोसेस ज़्यादा है।
हाँ, प्रोसेस
सबसे
है,
ज़्यादा
फिर वो क्या क्या करते हैं।
मेडिकल, ये वो बहुत सारी चीज़ें रहती हैं।
राइट राइट। अक्षय राठौड़, गुड मॉर्निंग।
Good morning, sir.
राइट राइट। तो आज जो ज्वाइन कर रहे हो उसमें से हाउ मेनी पीपल आर, मतलब लग नहीं रहा मेरे को ग्रीन हाइड्रोजन लाइन से कोई है। हम्म। मदन सिंह जी, आपने हाथ किया है रेज हैंड, क्या? बताइए, कुछ कहना चाह रहे हैं क्या आप?
हाँ, मेरा तो सर ग्रीन हाइड्रोजन प्रोजेक्ट नहीं किया है, सोलर का ही किया है।
अच्छा अच्छा अच्छा। ओके, कोई नहीं किया, मैंने ही नहीं किया अभी। मैं एबीसीडी नहीं जानता हूँ ग्रीन हाइड्रोजन की।
सही है।
रियलिटी तो यही है। आई डोंट नो
सही
सिंगल वर्ड अबाउट ग्रीन हाइड्रोजन।
है।
कैसे करें? 1 मिनट पेंडिंग है, देन वी विल स्टार्ट। लेट्स सी कौन कौन ज्वाइन करता है, क्या है जो भी है। मैं इसको। हाँ जी, गुड मॉर्निंग गुड मॉर्निंग। 6 people are connected. So 1 minute is pending. After that, we will start. Okay.
ओके सर।
Okay. We are starting. ग्रीन हाइड्रोजन एक नया वर्ड है। मतलब हाइड्रोजन तो पहले से ही चल रहा था। उसको ग्रीन क्यों बोला है, क्या डेफिनेशन है, और कौन कौन से हाइड्रोजन है, ऑल वी विल डिस्कस हियर। एंड व्हाट इज द ग्रीन इमेज, विच इज द बाय प्रोडक्ट बेसिकली ऑफ ग्रीन हाइड्रोजन। तो व्हाट इज द यूज ऑफ ग्रीन अमोनिया? ओके, सो first I am starting with a quiz. Okay, what is your knowledge about the green hydrogen? That we will check, right? So I am putting, first we, when before starting we will do this quiz, and then after completion. Okay, let's start. This is the link I have shared in the chat box. Let us start. क्या नॉलेज है आप बताइए मेरे को. हाउ मच many marks you got out of 10? Once you got the link of quiz. Hello, are you there?
yes, link आ गया है सर.
Yes, yes.
Yes, yes,
Again,
sir.
again I am sharing. Yes, yes. Again I am sharing. You just start taking this quiz. It will hardly take 2-3 minutes or 4-5 minutes. You just start it. Okay. I want to check. You just tell me कि आपको 10 में से कितना आया मार्क्स, so that अपने को पता लगेगा कि अपने को नॉलेज कितनी है अबाउट ग्रीन हाइड्रोजन या ग्रीन अमोनिया वॉट एवर. ओके. Quiz link is given in chat box. You just check and respond all 10 questions so that we can come that out of 10 how many marks we are getting, what is our score, what is our knowledge about the green hydrogen and green ammonia. After training again we will do this quiz and we'll get the answer. So don't remember what you have earlier replied. So don't try to remember. Just think, do that, and check the score. Once you completed, please tell me. You just put your marks in chat box, your name and your score. Sekhar Raja submitted and he got 6 out of 10. Good, good. Raja Sekhar has done fast this quiz. It's great. Great, great. Akshay Rathore submitted 3 out of 10. Quiz link is shared in the chat box. Everyone has to participate and get your score. So Akshay got 3 out of 10 and Shekhar Raja got 6. Good. Jagdish Mohanta got 5 out of 10. Good. So overall, we can say around average, we can say 50% knowledge there. I am just sharing again the link whoever newly joined. Okay, who are joining late, they can check chat box later for this quiz, or after the training they can do. Okay, Ravi Kumar Singh, yes, tell me. Unmute your mic and tell me. Ravi Kumar Singh. Hello. Ravi Kumar Singh, do you want to say anything else? You raise hand.
No, I think he's wrongly pushed the button.
Wrong link is shared. Oh, this one. Earlier, what was the link? 1 minute.
No, sir, I think he's wrongly pushed the button. I think so. That's why he hadn't speak anything.
Okay, so right now it is okay, na? Quiz.
Yeah, quiz is okay.
Okay, okay. Right. So, how many is done? You have done? Priyans, you have not submitted? Shekhar Raja done, Akshay Rathore done, Jagdish Mahanta done, and Sachin. Good, good. So, it is okay. Now we are starting. Let me start presenting. So, can you see my screen?
Yes, sir.
Yes, sir. Yes.
Okay, okay.
Yes, yes.
Right. So, first of all, I want to tell you what is the green hydrogen and green ammonia. Earlier also, green hydrogen means hydrogen and ammonia. Ammonia is just like fertilizer, you can say. Already we are using hydrogen, also used in the steel industry, fertilizer industry, okay, in many other industry also, in marine also. But why it is called green? Okay, so green means initially in our renewable energy, means in our India basically the definition is given worldwide also. We will use the energy used to produce hydrogen and ammonia should be renewable energy source, which may be solar or wind plus storage. Storage means it may be battery energy storage system, or it may be CSP, concentrated solar power, sodium nitrate and potassium nitrate, Utentic mixture of sodium nitrate and potassium nitrate. And other one is the PSP, means pumped hydro storage, yeah, pumped storage plant. PSP you can say, means it's just like a hydel power plant where through pumps are run through the renewable energy, solar and wind only. They put the water in the reservoir, which is upper side, mean the high level, and then through penstoke water comes and it again generate the energy, means it is again called uh, PSP, pump storage plant. Means ultimately there is no other energy use on total green energy. Okay, but why battery energy storage or this storage is used? The reason is that if we install any plant means for power. So you know renewable energy, solar and wind cannot continue give the power. If you want to run the plant continuously at 100% capacity, you need power round the clock. So either you have to be solar, wind, and other storage plus grid also. Okay, like that you have to be there. So this is the funda. Means now again question came. I will discuss in later next slide. What is the definition of green hydrogen? When it is called green hydrogen, basically. Okay, so earlier definition was different. This is target. I was just the definition was different. You might see in this slide. This one. Okay, what is the definition of green hydrogen, green ammonia? Means earlier India was telling I produce 1 kg of hydrogen, and due to that process, whatever the energy I am using, no doubt I have to use renewable energy only, coal I cannot use. Then, yes, it is emphasized that you have to use only renewable energy source only, but still this definition is not clear. CO 1 kg of hydrogen if you want to produce, then equivalent, if 1 kg of CO2 is emitted, it is called green hydrogen. That is the initial definition of India. Further, when the conference happened, first conference, then someone from Japan told that 3.4 kg of CO2 if emitted by producing a 1 kg of hydrogen, it is we will do it 2 kg of CO2 equivalent to, means ultimately still globally the definition is not clear, but there is a consensus that we have to use only renewable energy for the production of green hydrogen and green ammonia. Okay. Now, if we talk about these targets, okay, definition is clear. Once you have produced hydrogen, means green hydrogen, okay, through by using the green sources of power, or how it is made, it is just a electrolysis, means you should need the water. 1 kg of hydrogen need 9 kg of water. Okay, to produce 1 kg of hydrogen, we need 9 kg of water. So wherever the water abundant is there, abundant quantity like Gujarat, coastal area, Tamil Nadu, Odisha, okay, these are the state where there is a huge opportunity of producing green hydrogen because water is there. Okay, coastal area is there. Maharashtra also. So that is one thing. Then electrolysis. Electrolysis means breaking the H2O into H2NO, removing the oxygen and producing the hydrogen. So this electrolysis process, we need electrolyzer. There are different type of electrolyzers we will discuss later. So this electrolyzer means electrolysis process need power. Okay, that power should come through the renewable energy. And now again we talk about the renewable energy. I will talk later what is the mix to be used for solar. You can go 100% solar, you can go 100% wind, you can go 100%, but you cannot achieve 100% capacity utilization of the electrolyzing plant. So you have to go in mix. Hybrid structure means solar and wind plus storage. Storage may be CSP, concentrated solar power, CSP storage, thermal storage, that is called thermal storage, or normally in India or in out of India also, they are going in pumped storage plant because water is already there. So they are going in pumped storage plant, mainly solar, wind, and PSP. This is the basic mix. Okay, what I am showing, what India has targeted. India has targeted that we have to achieve. Right now, we have installed around 200 gigawatt renewable energy. That is mix of solar. Maximum is solar. Around 60% is solar. 40% and means 30% water wind and then other. Okay, mainly solar and wind are there. still 300 gigawatt we have to do by 2030, non-fossil capacity. Okay, and we are targeting 50% of installed capacity should be non-fossil fuels. Means our renewable energy should be 50%. While by 2050 the demand will also, by 2030 we are saying, but by 2050 our demand will so high that again 60% will be the coal and 40% will be the renewable, because demand is continuously increasing. So what is that? Reducing emission intensity of GDP to 45% below, means whatever the temperature, we have to maintain the temperature at 1.5 degrees centigrade of the earth. So whatever the level was in 2005, on that level we have to reduce 45%. Okay, then we means 45% our energy makes a carbon emissions process, either we have to go for electrical vehicles. Okay, the carbon emission is more, like other production also, like steel, okay, fertilizer, hydrogen, but they use the coal thermal power plant. So that we have to reduce. The carbon intensity is high. Like transportation is also a major contributor. So we are going for EV like that. And by 2047, we have independence. Okay, energy independence means our total power we will means generate ourselves. We will not procure any power from other country. And 2000 meeting the demand itself. 2070 net zero. What is the net zero? Carbon neutrality. Net zero. Zero greenhouse gas. Name is greenhouse gas, but gas is coming like methane, CO2. They are the greenhouse gases. That will be zero. When it will become zero? When we will go with totally renewable energy. And in electrical means whatever the carbon emission is there, we will reduce each and every. Okay. What is a green hydrogen standard for India? India means standard, what I have told earlier. Green hydrogen means the hydrogen production should be through the renewable energy. Okay. And in that also, not limited to only electrolysis, while we are going only for electrolysis, but conversion of biomass is also put in that, in this one. Means through biomass, we are also producing. Biomass means this grass or whatever, okay, rice, bagasse we can say, biomass plant we can say. That is also, if we are producing hydrogen, that is also part of green hydrogen. Okay, and renewable energy also includes such electricity generated from renewable sources which is stored in energy storage. It means you can store the energy also, but that is also from the renewable sources, and or banked with, okay, whatever the applicable regulation we have to follow for banking. Means if you are taking from the grid, or if additional banking means additional energy is there, like for green hydrogen production you have installed 100 megawatt solar event, but for example your plant is in shutdown or in maintenance, but generation will be there. What you will do? You have to sell that power to the grid. Okay, that is facility also there, but the rates are different for that. Now, what is definition? Already I have told you. Now you remember simply, green hydrogen means using the renewable energy sources, means solar, wind plus and other any storage, and we have to control also the CO2. CO2 we have to control maximum 2 kg. That is the right now India standard. Or we have to achieve in coming time 1 kg CO2 by producing 1 kg of hydrogen. Now again we are discussing the what is the green hydrogen use, where is the use of green hydrogen. Okay, we have not worked in this industry, but refinery, feedstock, for as a feedstock hydrogen used in fertilizer industry, in refineries. Iron and steel is the major consumer basically. Okay, so iron and steel, like Tata Steel, JSW Steel, okay, many other, even Reliance refineries there, bulk chemicals factory also, they are the feedstock, the hydrogen is used there. Other use of hydrogen is what? One use is that we have to use as a feedstock, means inputs. Okay, in refinery, fertilizer, iron, steel, and bulk chemical. And another work is hydrogen that energy storage. In fuel cell, like if you are generating hydrogen, If you are not using for your own purpose, like for example, for a refinery is there, you need 100 metric ton hydrogen, but some days maybe possible the hydrogen is generating, but it is not used. You just store it. Yes, storage is another concern we will discuss, but you can store it in the fuel cell and later you can use it. Means energy stored through hydrogen is called fuel cell, where through hydrogen they save the energy and it can be used later. Okay. Another thing is the blending with natural gas, LNG. We are already CNG gas, like 100% CNG buses are running. For example, in Delhi, we can mix some part 25% hydrogen in that. Okay, and blending with other natural gas, we can use it. Long haul mobility means so the truck and buses we run, which run long, very long distance they travel. Hydrogen is better for that. Costing point of view, it is reliable and costing point of view. Only long run. Again, I am telling we are adopting electric vehicle by 2030. Maximum we will convert all diesel petrol vehicle into EV electric vehicle. But for long hauling vehicle like truck and buses, which run in the long routes, they will use the hydrogen. But for that, we need to develop the infrastructure like hydrogen pump station should be there. Okay, how we are transporting. There are a lot of infrastructure needed. Right? Maritime means this is the cruise we can see. Transportation ships are there. They also use this hydrogen as a fuel. Now, expected outcomes by 2030. I am audible, na?
Yes, sir, you are
Are
audible.
you getting?
Yes, sir. Yes, sir.
Yeah,
Okay.
yes, sir, yes, sir.
Yes,
So
yes, sir.
if you are learning the yes, just in chat box put why yes. Okay. If you are
Yes, sir.
getting knowledge, you just put in chat box yes. Okay. I want to see who
And
are question. Pardon?
sir, one doubt.
Okay. Good. Niranjan Kumar is learning. Mukesh Kumar is learning. Janu Tikoni is learning. Good. Sekhar Raja is also learning. Priyans is also learning. That's great. Good. Okay. So we continue. Expected outcomes by 2000 means in green hydrogen mission. National Green Hydrogen Mission is launched in 2022, and accordingly, what was the targeted? It was targeted that we have to produce 5 million metric ton per annum by every year. Per annum means every year. Start from you can say by 2023, you can say 24 to up to 2030. Every year we have to produce 5 million metric ton. For production of 5 million metric ton, what we need require, we need around 60 to 100 gigawatt electrolyzer capacity, because we have to do the electrolysis. Through electrolysis only we have to produce hydrogen, not other method. Okay, so we need this electrolyzer. Again, we don't have electrolyzers plants in India. We are again importing that one. So technology advancement, R&D, lot of things is required. Again, now 125 gigawatt RE installation for green hydrogen GS2 means to achieve this production, we need to install around 125 gigawatt RE renewable energy. That may be solar, wind. Means that 500 gigawatt is different target, and this is another different target for this only green hydrogen. That is a different mission. Okay, that mission, your 500 gigawatt is that we have to be means to achieve this carbon neutrality that is targeted at the Paris Agreement. But this 125 gigawatt is separate for green hydrogen. So you can see if you are in renewable energy field, solar and wind, whatever, so still there is a chance for you in opportunity, either business opportunity, a job opportunity in green hydrogen projects also, because so much RE installation to be done. to achieve the green, to get the green hydrogen. Okay, 6 lakhs new job, 100 billion US dollar investment that is targeted, 5 million metric emission averted, means whatever the carbon million metric ton, thus so much carbon will be averted. Okay, by doing this one, because the hydrogen right now produced through the captive thermal power plant, either it is steel industry or either it is refinery, whatever, they have their own thermal power plant, captive thermal power plant, and they are using that energy right now. Either they are taking from the grid again, and that power will be either from coal or whatever. So ultimately, this is the major environmental steps taken by the government. Here, this is again question in hydrogen types, comparative overview of hydrogen types: green hydrogen, blue hydrogen, gray hydrogen. First of all, there is no color of hydrogen. Again, I am telling, don't get confused. Sometimes, if it is asked what is the green hydrogen, its color is green, blue hydrogen's color is blue. No. Simply, you can see the comparison. Green hydrogen will be made through the electrolysis of the water, and by using for that electrolysis, power will be used from the renewable energy only. Okay, this is the difference. And blue, natural gas with carbon capture. Okay, natural gas, if you are using natural gas to produce the hydrogen, that is called blue hydrogen. Gray hydrogen without carbon. Natural gas is there, but without carbon. What is the carbon capture? Carbon capturing is another thing. Means when you are producing any hydrogen or using natural gas, then wherever the carbon emissions is there, that carbon is captured, means through some process. Carbon capturing is a process basically where carbon is captured, and before it left to the environment, it is you can diminish, you can say like that. This is the carbon capturing, means environment you are not leaving that carbons into the environment. In blue hydrogen, carbons are going in the environment, means using natural gas, but in gray hydrogen it is not happening. You have the carbon capturing system is there, that is capturing the carbon, or it is not entering in the environment. Okay, this is the difference. CO2 emission, green hydrogen zero hai, blue hydrogen low emission due to carbon capture, and high CO2 emission. Like in gray hydrogen is the bad hydrogen, means high CO2 emission, because without carbon capture is there. Okay, understand? Production process, electrolysis of water. I already, H2O is the water. H2 and O, you just through electrolysis you have to break it two part. Okay, so that is one thing. Blue hydrogen, steam methane reforming with carbon capture. This is the production process. Steam methane reforming. Methane, you understand, CH3. Steam methane reforming without carbon capture. Cost $3 to $6 per kg. Green hydrogen cost comes $3 to $6. Right now it's around $5. If $1, if we assume 90 rupees, so it comes around 500 rupees. Okay, per kg. Per kg 500 rupees is the green hydrogen cost. You have to forget blue hydrogen, gray hydrogen. It will almost by 2030 there will be no such blue hydrogen, gray hydrogen. Okay, so cost, and there's a blue hydrogen cost is only $1.5 to $2.5, and gray hydrogen are very lower cost. So the industry is using this hydrogen because it is lower cost. If they go right now, but right now why this cost is high, $3 to $6, around $5 per kg? Why industry will use this one? But if there will be regulatory, means just like RPO was there, like any regulatory will be there, where you have to use it is green hydrogen only. You cannot use the blue hydrogen or gray hydrogen. You have to. Then ultimately they have to adopt it. Now technology will come, like the solar rate was 17 rupees per kWh in 2012. Now it has come 2.5 rupees per kWh. So competitions will be there, technology advancement will be there, infrastructure development, you can say. Okay, huge investment comes from the outside. Same will happen in the green hydrogen, and government is very positive. Government of India, very positive investment as coming here. So it will be also the rate. This cost will also come to $1. It is target by 2030. It is targeted. The cost will come $1, but it will not come, but it may come up to $2. Okay, by 2030. Now I will next slide I will show you. Energy requirement, high energy from renewable, moderate energy, byproducts. What is the byproduct? When you are producing green hydrogen, byproduct is H2O, electrolysis. H2 is used that is hydrogen. Oxygen is left in the environment. That is harmless. This is the byproduct. Blue hydrogen, CO2, but it is captured and stored. That is used again, captured and stored. But in gray hydrogen, released into the atmosphere. What I am saying. Okay. Environmental impact, you can say minimal in green hydrogen because we are using renewable energy source. Lower emission that the gray still release the fossil fuels. Okay, or high environmental impact in gray hydrogen. So this is the comparison. You can see scalability also. You can check current use early stage. Now, green hydrogen in early stage, gaining momentum globally right now. Okay, blue hydrogen used in industries transiting to lower carbon solution. Okay, because with carbon capture they are going. Na? So whoever the industry want to practice that one, okay, lower carbon emission, they are adopting this carbon capturing system. Same in gray hydrogen, most common hydrogen production method. Right now, it is very cheap, cost is very low for the gray hydrogen. So most of the industry, like either steel, fertilizer, refinery, or marine ships, they are using this hydrogen only. Which gray hydrogen is mostly used right now, but by 2030, green hydrogen will be only used. Safety, ammonia already we have discussed. I just one thing. Okay, no doubt you see this one so that you can come to know hydrogen, ammonia. What is the difference? Ammonia actually first we have to. I just tell you the process first, then we'll come this side.
Sorry to interrupt you. Whether we are
Pardon?
in the slide number 5 only or we have changed from there.
Achha, right now you are which slide you are seeing? 5 number.
Six number slide, sir.
2,
Expected
3,
outcomes.
4, 5, 6, 5. This one expected outcome. After that slide is not changed. This one comparative
No, sir.
hydrogen types. I told you.
For me, it is not
Huh?
changed. That's why. For me, it is not changed there.
Why?
That's why I don't know, sir.
What about
Now it is.
others? What about others? What about others? Hello? What about others? Which slide is right now visible to you?
Now for me, it's the seventh slide.
No, you don't
Comparative
tell me the
overview of
slide. Okay. So that is we have already discussed. Okay. That is already
Right.
we have discussed 7th slide. Okay. Now I am going with next. Okay. This one.
No, I think
Safety
Niranjan
handling.
also having the same. He's also seeing the slide number 5 only.
Why it is not changing? There is a system, your system problem, I think. Others can tell me. Any other can tell me? Don't go on number, go on the content basically. Okay. So hydrogen type we
Yeah,
have
noted.
discussed. Ammonia, I am telling you, you don't go on now. Before that, I am just telling you what is the ammonia basically. Green ammonia. Okay. So I am just tell you the what is the this one. Okay. This one slide is visible. Nitrogen production. Can you see?
Yes, sir.
Yeah, now it is visible.
Yes,
Okay.
yes, sir.
So
Sir,
what I am
whether this
telling.
meeting is recording or how it is, sir?
Yes, sir. Recording is there, and it will be shared to each and every community member or who is attending this one. Okay. Don't
Right.
worry.
Okay, thank you.
Who are,
Thank you.
who are the permanent? Who has taken already? I told you in rupees 365. Every webinar for 1 year will be free because they will become the member of the community. Okay, many
Yeah,
other
noted.
advantages are there, but the major advantage is that you can attend free all webinar, and even this recording will be shared. Either you are attending or not attending. Okay. So
Okay, thank you.
we are also giving the certificates. Okay, membership certificate also we are providing, and also we are planning the web-based community where you will be given the login ID. Okay, and many other advantages there. Means once a year there will be a workshop we are planning, so all will be called there. But workshop attending is free, where you will good networking. Okay, networking will be there, and you will learn lot of things uh, about this renewable energy space. Okay, so that is another advantage. And in last also we will online we will, or either online or in workshop itself, we will organize the awards for the best contributors in the community. Okay, so that we are watching who are the contributing positively and constructively and regularly, that will be get award. Okay, we are making this community as a professional community in coming time. It's our target. Okay. And okay, so let's discuss about this nitrogen. Ammonia, when we are discussing what is the ammonia, basically, ammonia is NH3, simply. Okay, so NH3 means what is the production style? I just show you that one formula so that you will clear to know about this one. Yeah, here you can see. Yeah, you can see green ammonia synthesis. What is the synthesis? Again, when we are talking about the costing of green hydrogen, only thing is that renewable energy you have to use for electrolysis, and electrolysis you need the electrolyzer. One cost part is that electrolyzer cost, which is around 30%. Okay, and another is the renewable energy, which is around 60 to 70%. With storage, you can say, because you have to go with storage, because wind CUF, you can say, PLF is around 35%, and solar is around 20%. So both, if you are using a hybrid of that capacity, it comes around 55 to 60% only. So what about electrolyzer to run in the high full capacity? For that you require either grid power. Grid power you cannot say either through open access you are taking. RE plant is some other places of you, and you are taking through open access, then that is the other thing. One thing is that you have to go with storage. Storage means maybe both storage, battery energy storage system plus PSP or CSP also. Consider thermal storage you can go. Okay, so maybe in Khavda, Gujarat, NTPC may plant the CSP. Okay, first time in India thermal storage will be. Right now only one or two plant is operational. That is the CSP, concentrated solar power. But both are without storage. Provision was left there for thermal storage, but now it is not still not installed. So now for this green hydrogen production, thermal storage first time in India may come. Okay, let's see green ammonia synthesis. Once you have produced the hydrogen, okay, hydrogen produced to the water electrolysis. Now this green hydrogen which is produced, further process is the synthesis. Means ammonia, to produce the ammonia. If why ammonia is produced, that also I will tell you. We will see the comparison, because hydrogen we need to keep at high pressure. It is not easy to transport, it is not easy to store, it is not so safe. Okay, costing is very high, storage and transportation costs. So it converted in the ammonia, which is a normal temperature. You can say ambient temperature. We can transport it and use it. Only a highly corrosive. If we are transporting tank, then we have to use the insulated tank like that. That I will discuss later. So ammonia NH3 is pure. NH3 formula is a chemical formula NH3. Ultimately, what is the N? N means nitrogen. Nitrogen, we are very well aware that 78% in air. If we see the air, 20% around oxygen is there, okay, and 70%, around 78% is the nitrogen. So that nitrogen is extracted from the environmental air. So what will be that process is called ammonia is produced using the Haber-Bosch process. Haber-Bosch process. What is that process? A question was there na, in the quiz. If you see, a question was there. This one in the quiz. Produced in the Haber-Bosch process, which is the most common industrial method for synthesizing ammonia by reacting nitrogen and hydrogen. Nitrogen you have to extract it from the environmental air. Then this is produced with the green hydrogen, H2. That process is called Haber-Bosch process. Always remember this one. Okay. Under specific condition, this formula is fine. And N2 is the nitrogen, 3H2 is this one, green hydrogen, then 2NH3. Okay, this is simply chemical formula. So the reaction is exothermic, meaning it releases heat. High heat is released. How it requires high pressure and temperature to process efficiently. Okay. So this is the ammonia. How ammonia is produced? Ammonia is NH3, means green, once green hydrogen is produced, you need to extract nitrogen from the environmental air, which is 78% available. Then nitrogen and green hydrogen in process. That process is called Haber-Bosch process. Through that we produce the ammonia. Or what is the ammonia? That we will see. Okay. Here we were discussing what is the safety is first we need to understand the difference between both. Okay, what is the hydrogen, what is the ammonia? Flammability, if you discuss about flammability, why we are going with ammonia means if you have to transport long distance, like in Europe you want to send the green hydrogen, first you have to convert green hydrogen to ammonia here itself, then this ammonia will be transported in the ships, that will be the cheap also, and again it is converted from ammonia, because ammonia is the carrier of green hydrogen. Again green hydrogen will be from ammonia to green hydrogen will be converted there. This is the way, like if we see the DC line, 800 kV DC line, what is there? This DC from AC, we generate AC only, AC is converted in DC, then through DC line you can see the DC line or long distance line, power is sent to the DC, then again the receiving station, this DC is converted to AC. Okay, as well. Same is the case in hydrogen ammonia, but why we are doing so, we can understand from this slide. Flammability, extremely flammable, 4 to 75 flammability range. Not flammable, ammonia is not flammable, first of all, okay, in normal condition. Explosiveness, highly explosive hydrogen. Ammonia can be exploded under specific conditions with a high concentration if is there. So ultimately hydrogen again highly explosive. Toxicity, non-toxic, hydrogen non-toxic, but ammonia is highly toxic. Okay, causes respiratory issues, burns and irritation. Handling, use non-sparking tool, avoid open flames. Ensure open flames we have to avoid. Use corrosion resistant equipment. What I am telling you, tanker, insulated tanker for to avoid the corrosion basically. Na? Skin and eye contact. Storage under high pressure. Hydrogen at high pressure storage as a cryogenic liquid. Okay. Cryogenic means we have to cool it at a very lower, you can say either minus 253 degrees centigrade, we have to cool it. Then only we can store it. While ammonia can be stored at minus 33 degrees centigrade, just like a refrigerated liquid under pressure. Okay. Same detection, hydrogen specific leak detector required, ammonia detector available already, but for hydrogen specific we need this detection. Okay. Ventilation, high ventilation required, adequate ventilation required, personal protective equipment, PPEs, flame retardant clothing, goggles and gloves, chemical resistant means now you can understand the difference. Hydrogen and ammonia, what is the basic difference? Okay, emergency procedure also we see: shut off gas supply, evacuate the area, avoid ignition sources, evacuate the area, use water spray to disperse water. Means if you see this sheet, you can come to know ultimately handling of hydrogen at high pressure, and even if we make it cryogenic, we have to go at very lower minus 253 degrees centigrade temperature. But it's not easy to store it and then transport it. Also, it is not so much safe. We need to take care of everything, and according our infrastructure should be like that. Awareness within the public should be there. So ammonia is more focused right now. Okay, we are converting it for long distance. Like if any steel plant is there, they need hydrogen. What they will do? They simply use the renewable energy, solar wind. They will install the plant, take the power, do the electrolysis. Water should be there, electrolysis, and whatever the hydrogen will be produced, used in the steel plant itself. Means there is no ammonia is required. But if you want to sell it, if you want to export, or if you want to send it to your other steel plant, for example, at that time you have to transport. Then it is not easy to transport hydrogen because it is storage and transportation is costly and unsafe, not so safe. We have to take care basically. Okay, in cylinder also 700 kg pressure required if you want to. So it is also very typical. So that's why ammonia is now the best carrier for hydrogen. Methanol is also there, but ammonia is the best carrier. Now, when we are talking about that, it is a standard. It is internationally accepted standard right now. If whatever the hydrogen we will use, that will be through the renewable energy. What should be the mix? Means if tentatively discuss what should the better mix. Solar energy should be used 40 to 50%. CSP with thermal storage we can go. Okay, in evening hours if you want to use the CSP, we can use it like Gujarat and Rajasthan. The state, because solar is good in Gujarat and Rajasthan, so we can go solar energy there around 40 to 50%, and we can use the CSP as a storage we have to go. If we want to use the 100% capacity of the electrolyzer, we have to go with the storage. Wind energy 30 to 40%, high in coastal area like Karnataka, Gujarat, Tamil Nadu. In coastal area, why we are going offshore wind? Because in coastal area only the water abundant water is available, electrolysis will be done there. Then for power we will use the offshore wind, that is a high capacity machine will be there. So we are also going with offshore wind also. Understood now? So all these are planned properly, but it will take time. It will take by 2030 only we will achieve some offshore wind and this green hydrogen plant, all these. Okay, some electrolysis plant we will see there. Right now only some prototype plant like 5 megawatt in this Bikaner by ECMA is running, and other also running some prototypes by NTPC, okay, with GACL 35 megawatt. All these are running right now. Pumped hydro 25 megawatt by JSW. So pumped hydro storage, if we are going 10 to 15% during night and cloudy days. Pumped hydro storage, already I told, through pump, the water is pumped upper side in the reservoir. That water, these pumps are run through the renewable energy and solar or wind only. Solar is daytime, wind in 24 hours. And with storage also we can go, and that water, then water again through penstock comes to the turbine, water turbine, okay, and it makes the power. So that is a right now for green hydrogen plant, everyone going with solar, wind, and pump hydro storage, PSP, pump storage plant. We can also go if we are not getting full means power 24 by 7. We can go also some part battery energy storage, BES, battery energy storage system, 5 to 10%, lithium ion and flow batteries. Okay, right now only no lead acid batteries are used, only lithium ion batteries are coming, and flow batteries also. Biomass, hydrogen fuel cell also we can go to 5 to 10%. These are only options for the storage, and grid power is another option. Now, I just want to show you one video, okay, and then we will discuss about the costing. What is the estimated cost of green hydrogen, green ammonia? Okay, given by the Niti Aayog. We will discuss that one. 1 minute. I just run a video for you so that it will better understanding will be there. One minute. Let me check. This is basically the ammonia. Actually, we will learn this one. Okay.
Sir, video is in mute.
Yeah. 1 minute. You are unable to see?
No, video is visible, but voice we are not getting.
Voice not coming.
Yes, video voice we are not getting, sir.
Sir, for this video, it is better to share the link in our group. That means everyone can view this video.
Okay. No issue, no issue. Okay, what I do? It is also good option. Right. You are right. Okay, no issue. Again, I have to share that one. Okay, so window is clear.
Yeah, now it is visible.
1 minute. Okay, we are discussing about the costing. Okay, what is the costing? Basically, estimated cost of green hydrogen and green ammonia. Simply, you see here both hydrogen also electrically based. We are not using natural gas. Already, I have told the green hydrogen means it will be pure renewable energy. And
Sir, sorry
what
to
will
interrupt you at
pardon?
this time. Sorry to interrupt you, sir. Is it possible to put it in a presentation mode, sir, actually?
Uh, it is already in presentation mode, I think.
No, sir. We are seeing the slides also in the side. It is not in the presentation mode, I think so.
Hey, it is visible on a nay. 1 minute. Reading view. One in the slide slow.
Yeah. That is the slideshow. Correct, sir. That
Slide
is the
show.
slideshow.
This is the slide show.
Correct, sir.
Now it is visible.
Yeah, it is visible, sir.
Same I was doing earlier. Okay, no issue. Okay, we are discussing about this slide. Estimated cost of green hydrogen and green ammonia. Okay, Niti Aayog has given this sheet. Both are electrically based. What is the rate in 2023? Same right now. Okay, not so much difference. And 2024 is also almost same. And 2030. What will be the difference? Okay. First scenario is that we are using the 100% solar. Okay, 100% solar if we are using, our PLF is around 19% or 20%, we can say. So delivery cost, what will be the cost per kWs? Around 2.43, 2.5, earlier told. Okay, so if the unit, our cost means electricity cost is coming 2.43 per kWs, then what will be the hydrogen cost right now? Right now, per kg, it will come around 4.2 US dollar. Okay, so around US dollar rate, 4.2. You can convert in rupees also by multiplying by 90 rupees, right? So this is the cost right now. Now what will cost of ammonia? Anyone can tell me why cost of ammonia is more than cost of hydrogen? Anyone?
Process cost is high, I think.
Pardon?
Process cost is high.
Yes, yes, yes. Yeah, ultimately, for ammonia, first we have to produce green hydrogen. Then further synthesis process, additional process was ammonia. Understood, na?
Yes.
So ultimately, always ammonia cost will be higher than the green hydrogen. First of all, you understand it simply, है ना? So cost of ammonia is coming 797 US dollar per ton. Okay, this is per ton. This is actually 4.2 US dollar per kg of H2. If you convert in ton, it comes around 400. Okay, so just double cost is the ammonia. Now, if we go with solar with storage, if any 4 hour storage also we are, either it is PSP are going or BESS we are going, the cost is almost double, 5 rupees you can say per kWh. Same solar is there, but with storage. And cost of hydrogen 4.02. Okay, and this one cost of ammonia, it is again coming 787. Okay? It's lower basically. This is a solar because efficiency increase. Now we can produce more basically in that case. Economy of scale we can say, because overall generation is increased. The total level LCO you can say, okay, levelized cost of energy it reduced here. Now, second in 2030, what will be the situation? If solar we are using with 23%, maybe technology upgraded, like we are using monopark to now another HDG, some new technology coming, bifacial also we have seen. So maybe efficiency CUF increase 23%. Then what will the cost at that time? 1.9 per kWh delivery cost basically, and cost of hydrogen will 50%. Right now, whatever the cost, $4.2, it will come to $2 US dollar per kg. That is our target. Actually, by 2030, we have to achieve. Right now, somewhere it cost is coming $6, $5 to $6 per kg, but we have to achieve $2 by 2030 by through competition, by developing infrastructure, by domestic electrolyzer. Okay, that we need to do here in India. Same in case of ammonia, cost is coming 50%, 797 US dollar per ton. Okay, it will come 422.64. Same if we go with storage cost is high, 3.34. 2.51, 100% storage cost will be high, and it will come 506.78. Okay, for cost of ammonia. Banking, what is the banking? Banking is on there. Banking means whatever the energy we are producing. Okay, if we have to sell it in the grid. Okay, so what rate we will get? That is also on 2.53, 2.29. Okay, this one. In that case, 461.97. Okay. So that is a comparison. You can say cost of gray ammonia at a 16 US dollar. Case price is 651 US dollar. It is on cost of gray ammonia. Gray we have already done is most dangerous. You can say gray ammonia. It is saying 16 US dollar. 16 US dollar. Okay. Gas price is assumed 651.11 US dollar. Okay. So all the scenario during 2000 case favors shifting towards green ammonia. Okay. It is not much more means normally we have to just a comparative we can see okay, why by 2030 this cost of energy will reduced and accordingly the cost of our ammonia and cost of hydrogen will be this one key challenges and suggestions to scale the green hydrogen economy. Okay, what we have to do? We have to arrange finance means capital. Okay, cost of capital is very important. Means either we are taking you can say debt and equity. You can say na. So that we need to see the financing will be at lower cost. Then only the feasibility for this green hydrogen, whatever we are targeting, 5 million metric ton will come. Then the finance will be easy. Means capital cost will uh, the finance will be at lower rate. Okay, so needs to be included in infrastructure. Harmonizes low cost of financing, bilateral, multilateral loan, blending finance, green bond, pension fund like that. Supply chain constraint. Again, the logistics that is a issue. So R&D in membrane is in electrolysis process. We use the different like AEM, PEM. Okay, that type of electrolyzer. So that membrane technology also free from critical minerals. Political tie-up for supply chain. Right now we are importing electrolyzer from China or some other countries. So we have to develop electrolyzer facility here itself in India. Then we need to import the membrane for them. Okay, right. So again, the supply chain issue should be resolved. Same managing regulation. Regulation, the government means the regulation is very necessary in safety point of view also, in storage, in transportation, and creation also we need the regulation. Okay, so international standard and definition of green hydrogen is first we fixed globally. There is no definition right now. Still all are working on that. What should be the standard? Because if you are producing any green hydrogen in India, want to export in the Europe, there should be a globally accepted standard. Then only this they will procure your material. This is the way. First we have to fix this one. Harmonization of the banking norms, establishing third-party green hydrogen testing and certification norms. This is also again any product like green hydrogen. If you are selling it, a special certification will be required. So any third party there should be a fixed what should be to be certified, what should be the parameters, who are the authorized parties to certify the green hydrogen. All we need to clear. Okay, grid code for green hydrogen from grid based power. That for grid, if we are taking power from the grid, another other than renewable energy, so what grid code we need to follow it. Building infrastructure like this transportation, storage, all these infrastructure we require. Pilot project for bunker based storage, R&D and pilot project for green hydrogen transportation. For transportation and storage also we need to see. That is a much big cost basically, but it is right now not discussed. De-risking mega project, issue sustained return on investment, policy continuity for the sector, demand creation. Demand creation is the measure. Means if you are planning to produce hydrogen for your own use, means your own captive use, for example, steel or refinery you have, you are using green hydrogen for your own use, that is okay. But if you are going to scale up and want to sell it, then demand should be there. There should be some customers should be there who will purchase that one. Either you have to export it, so what norms will be there, certifications, safety aspects, logistic, okay, government regulations, that all need to be finalized. G2G agreement for GS green hydrogen supply is similar to gas sector, like it is happening in CNG or whatever. Okay. Now we discuss about green ammonia costing. Okay. Green hydrogen already we have discussed. Electrolyzing is only there in green hydrogen. Here we can discuss green ammonia costing. Okay. 1 minute. Okay. Green ammonia costing. 35,000 to 50,000 per ton. Okay, in 1,000 I have converted basically to easily understand this one. It is higher than conventional. Green ammonia is right now costly because what is the cost? Green hydrogen. When green hydrogen cost is there, it comes to green ammonia itself automatically. So it is higher than conventional, which is 15,000 to 20,000 per ton. Okay, being cheaper feedstock. Feedstock means natural gas are used for blue hydrogen or gray hydrogen we have seen, okay, with carbon capturing or without capturing. So this is cheap. So accordingly, ammonia, if we make NH3, it is also cheap, which comes around 15,000 to 20,000 only. But if we go with green hydrogen, then cost of green ammonia will come around 35,000 to 50,000 per ton. Okay, it may reduce to 28 to 35 per ton subject to electrolyzer technology. Which technology? I will tell you the next slide. What technology are there in electrolyzer? PEM, AEM, solid state. Okay, we will discuss about and we'll see the difference. Right now, for renewable energy, PEM technology is the best. Okay, or AEM is very cheap. Okay, so 28,000, 30,000 per ton subject to electrolyzer technology improvement. What is the electrolyzer cost? 8,000 to 10,000 per kilowatt. This is the electrolyzer cost, 8,000 to 10,000. Alkaline technology, if we are using, it is a low cost technology. Alkaline technology is a low cost technology in the this electrolyzer. 12,000, 15,000 per proton exchange membrane, PEM, what I told. Okay, PEM technology is somewhat costlier than alkaline technology, 12,000 to 15,000. By 2030, this cost will be reduced and it will come to 4,000 to 6,000 per kilowatt, means almost 1 by 3. So green hydrogen, if we discuss about cost factors, renewable energy costing is around comes 65 to 70%, including the this storage, and 30% is the electrolysis cost. For if you talk about what the green hydrogen major component, only two component. One is the electrolyzer, or another is the energy, which is the green energy, renewable energy. Renewable energy cost right now is at higher level, means around it comes 65 to 70%, and electrolyzer around 30% for the green hydrogen basically. Okay, and transportation in liquid form, solid ammonia in marine ship, that is a different cost. BOS, balance of system, BOS is balance of system, that cost is different. Yeah, now it is a calculation, you just check later also, you can check for 1 million ton per annum green ammonia. If you want to produce, what to do? First of all, you need to use, you need 180 kg of hydrogen. Okay, 180 kg of hydrogen you need for 1 ton ammonia. 180 kg for 1 million, we calculate, it comes, it's just a calculation you can see. Okay, same for electrolyzer, I have calculated 9 ton watt hour per annum energy required. Okay, for electrolyzer. Electrolyzer is also calculated at right now we are calculating and taking. Okay, it comes around gigawatt. We are calculating for 1 million ton green ammonia. For that, electrolyzer power required 9 ton. Terawatt, 9 terawatt hour per annum energy we require, and capacity 1.47 gigawatt, and 180 kg hydrogen for 1 ton ammonia. This is the just parameter. RA requirement we have seen. Solar capacity we have calculated at 20% PLF, wind capacity at 35%. This is just a mix I have tried to calculate. You can check it later also. Again, pump hydro or battery storage, if we go, assuming around 5 to 10% of the energy demand will be managed by storage system to cover shortfalls. The storage requirement will be around 9 terawatt hour is total energy. If we assume 7%, so it will come around 675 gigawatt hour. Through storage it will be supplied. Okay. So green ammonia synthesis. Already I have told, green ammonia synthesis means to make the ammonia. Green hydrogen is there. Nitrogen, which is 78% available, we have to extract from the environmental air. Then we have to do a process that is called Haber-Bosch process, where we just this nitrogen and hydrogen, okay, under specific condition, then ammonia is produced by this process. Here is the percentage breakdown. Here just whatever I have already said. 1 ton of green hydrogen, the renewable energy cost comes around 30%. Energy storage 5 to 10%. Electrolysis 40 to 50%. This is actually cost for green hydrogen basically. Electrolysis got 40 to 50%. Storage and transportation got 5 to 10%. This breakdown highlights the bulk of the cost. ठीक है. Same you check later also. Already I have given a separate sheet of Niti Aayog. You just refer that one. It is just a sample. What are the component basically? If we talk about green ammonia, then renewable energy also come there, because for green hydrogen, energy storage also, electrolyzer and ammonia synthesis added. In case of green hydrogen, there is no synthesis process. Okay. In ammonia case, ammonia synthesis is also 15 to 25%. You just assume. Storage and handling cost around 5%, 5 to 10%. Nitrogen production, we have already discussed. Cryogenic air, okay, air separation. Nitrogen abundant in the atmosphere, around 78% nitrogen available in the air. Okay, this is obtained by separating it from the other gases in the air, typically using the cryogenic air separation or pressure swing adsorption. PSA is the technology. Okay. This is the Haber-Bosch process. Already I have told. In this Haber-Bosch process, just remember high pressure, typically around 150 to 250 atmospheric pressure, and high temperature 400 to 50 degrees centigrade. These are the basic. You can say the reaction takes place under this condition. If anyone asks you, so the temperature is around 400 to 500 degrees. What is the process? Name already I told you. That process, how ammonia is made, that process is called Haber-Bosch process. In Haber-Bosch process, what is the pressure? 150 to 250 and temperature 400 to 50 degrees centigrade. Okay. And one catalyst is also used, that is iron-based catalyst, often promoted with potassium or aluminum oxide, is used to accelerate the reaction and increase efficiency. Now ammonia, once the reaction is completed, we have to recover the ammonia. How ammonia is recovered, that is shown here. Okay. The ammonia condenses into a liquid at the lower temperature, allowing it to be separated from the unreacted gases, which is then recycled back into the system. So ammonia storage, that is important. Ammonia storage and hydrogen storage, we have already discussed. Ammonia storage. Ammonia NH3 is typically stored as a liquid under pressure or at low temperatures. Okay, very low temperature means ambient temperature, you can say. Under pressure, it is easy to store and transport in liquid from solid. Also, we can send it, and in liquid form using pressurized tank. That is the insulated. Okay, insulated tanks to avoid the corrosion, which is the reason ammonia is considered a potential fuel carrier in the future. If anyone asks you the why ammonia is best carrier of fuel, okay, green fuel, you can say green ammonia. You can say it's very easy to store and easy to transport. Cost is very lower than green hydrogen. Okay, so it's the best fuel carrier in the future. Water already I take 1 ton hydrogen required 9 ton water. The water calculation basically. Okay. Why I am saying green hydrogen or green ammonia demand by 2030 will be around 210 million ton. This will be the demand. For India export potential is around 3.7 million metric ton. We are already planning 5 million metric ton per annum from, you can say, by 2024 to 2030. And out of that, we can use 2.3 for our own use to 1.3 million metric ton. Other 3.7 million metric ton we can export to Europe countries. Okay, European countries. There is a huge demand basically. Or why India is best? Because there is a water availability is very high. All maximum Tamil Nadu, you can say Gujarat, okay, Maharashtra, all are in Odisha coastal areas. So water is there. Renewable energy, because best for solar and wind. If we discuss about that, that is also in Rajasthan. You can say Gujarat. They are Karnataka, they are good for solar. Accordingly, wind also. So overall, the situation for green hydrogen is best for India. That's why we are not only planning to satisfy our own demands, also planning to export. Okay, around 3.7 million metric ton per year. India hydrogen demand will go up to 5 to 7 times. Again, our demand will also increase. By 2050, it will go up to 5 to 7 times because infrastructure is continuously developing. Okay. Now, this is the 50 to 50 MW RE for 1 ton of hydrogen. Electrolysis based on efficiency of electrolysis. That same I have told you for 1 ton of hydrogen through electrolysis, how much units are required? That is 50,000, say 55,000 units kWh is required for 1 ton of hydrogen. Same for ammonia, green ammonia, we need 33 MWH, means 33,000. Yeah. Anyone? Yeah. So, demand creation, you are getting, na? Just in chat box, say, yes, I am getting. I want to see you are engaged or not.
Yes, sir, we are engaged, but we have some issue on the network. Actually, the presentation of the slide is not showing properly. You are discussing something, but we
And
are seeing the
it
previous slide.
depends. It depends on your network also. My network is okay.
Okay,
I
sir.
am at Wi-Fi. Okay. If your network is not
Right.
okay, then it will be issue because ultimately I am sharing the screen. Na. You
Yes,
have
sir.
to
Yes,
get
yes.
Wi-Fi based network only. Then only you will get okay
No,
immediate
understood.
response.
Understood, sir. For this thing, we can confirm after changing the two slides and the screen is visible or not. Like that, you can confirm, sir. It will be
Pardon?
better to ask to no, no. If the slide is changed, that you can also ask the people whether the slide is changed or not. That will be better to
Hey,
us to
no.
follow you.
If I will ask, the flow will break. But better you
Right,
can raise hands. That is the facility, or you can just unmute and you can tell. Excuse me, like that. You can tell. Okay, that is.
right. No problem.
I will share this one also. Okay, recording will be
Okay,
shared.
sir. Fine.
So
Fine, sir. Fine. No
recording
problem.
again you can view. Okay, not
Sure,
the
sir.
issue.
Sure. Thank you. Thank you.
Okay, we are 1 minute. Yeah. Yeah, this is the demand creation, incentivize supply. I mean, what to be done, man? Strategic intervention. You heard about site. Site is a basically a support from government of India. Strategic intervention for GS2 transit, green hydrogen transition. Site SIGST. Strategic intervention for GS2 transition, मतलब green hydrogen transition. For that, what government is doing, they are just supporting CFA, Central Financial Assistance, direct financial incentives for electrolyzing manufacturing per kilowatt capacity wise and green hydrogen production per kg. Okay, so there is separate. You can see site if you will put in Google or anywhere, you will get all detail in government in MNRE site also. What are the site SIGST? If you open the green hydrogen mission, National Green Hydrogen Mission, okay, National Hydrogen Mission. If you will open that site, also you will get this detail. Yeah, key enablers. Key enablers means what we have to do. We have discussed that yes, we have to go for carbon neutrality. We have to reduce the greenhouse gases, and for that already we have started adopting renewable energy. We are going with electrical vehicles also, because transport is also a better major contributor for this greenhouse gases. So we are going that one also. So for green hydrogen, another fuel we have adopted. What we have to do for that? We need resources. Means if power 125 gigawatt by 2030 we have to install. Right now, by 2022 also we planned 160 gigawatt, but we are not reached there at that time. So right now 200 gigawatt, or this is 2024 is almost got it. From 2005 to by 2030 we have to install 300 gigawatt. That is a safe rate, and for 125 gigawatt for this green hydrogen. So this renewable energy, banking, storage, transmission means transport. You can say finance, transmission also infrastructure, land, water. These resources we need to see. R&D is must. Result oriented, time bound, including through PPP. Okay, grant challenge and R&D is must for our local content. With this electrolyzer plant means domestic itself. Then only the rate cost will be ease of doing business, simpler processor, logistic, all this, taxation. Even the this definition should be clear. Certification. There should be standardization globally, okay, for this green hydrogen, safety standards, certification, quality norms, okay, and all other norms for export or import also, that to be fixed. SEZ commercial means if you are developing in the park, whatever the if you are developing in the park or SEZ special economic zone, that what are the incentives to be given by the government. That I am coming in that slide also. Different states are launching different incentives for green hydrogen, that we will compare. Next slide. Same infrastructure and supply chain. Like if we need to transport hydrogen, then we need piping, we need the tankers, this facility, then fuel stations. Because if vehicles, long haul vehicles, we are talking for to be run with green hydrogen, then we need the fueling station also, hydrogen, like just like CNG, we need some. And we need the piping also to so that the hydrogen where is produced can be sent there. So that also see, or either it we have to convert it the ammonia, green ammonia, then again through synthesis process, through ammonia to hydrogen we have to do. So that infrastructure also, regulation and standard is very important. Testing facilities, standards, okay, regulation, safety, certification, skill development is very important. Here I want to update you. Right now, NSDC, National Skill Development Corporation, is focusing on the skill development. They have chosen many institute to to provide the training for solar under the Surya Mitra also, and for green hydrogen also. Green hydrogen technician, you can say. Earlier also I posted in LinkedIn. So we have also a center there, means Ajmer, which is RDTC, a regional driving training center. That is also because the driver also should be cautious in environment. They should also be trained for the best environment friendly practices. Like if you are using trucks and the petrol and diesel you are using, you should go with the green hydrogen vehicle like CNG or means electric vehicle. You have to adopt. So what we have planned there, we are training, we are giving the training for green hydrogen and solar both under the NICE. The NICE is the nodal agency, a National Institute of Solar Energy. Okay, that is looking after NICE. Okay, NICE, National Institute of Solar Energy. That is the nodal agency. So through that, we are providing that training in the solar also, and green hydrogen also. We are starting very soon with the TUR and all. So same, you can say many other centers are in India. You can check your nearby. They are providing this training. You should go because it's free training from the government of India. It's free training, 90 days training, free accommodation, free food, free security. Everything is free. Okay, you will get the certificate and you will get the training from the certified trainers. Okay. Next, action plan, regulatory. Already we have discussed PESO. PESO is basically this to make this all this rule like this. PESO to facilitate amendment of relevant policies, rules like gas cylinder rules, static and mobile pressure vessel rules for hydrogen. Okay, means if we are coming with green hydrogen, so whatever for other gases rules or regulations are there, accordingly we have to customize for this uh, green hydrogen. Okay, all regulatory norms should be customized for the green hydrogen in a very safe manner, so that and awareness among the people is also necessary. Right now, very few people know about the green hydrogen. Okay, now because it is earlier it is coming only industrial purpose only. Okay, industrial purpose only we are using. Now it is in the long hauling vehicles also we are going to use. So it will come in public. Okay, this is the emission abatement with adoption of green. Once Niti Aayog is given us that if we use the green hydrogen, so what carbons metric ton equivalent in metric ton equivalent, that is called emission abatement, we will achieve. So it is showing if we use the green hydrogen by 2037, by 2032, we will get 30.19 metric ton CO2 equivalent. We will not live in the environment. We will save the environment. 30 metric ton. By 2037, 56 metric ton. By 2042, 88. And by 2047, around 123 metric ton CO2 will not be left in the environment if we adopt the green hydrogen. Okay. Will largely be seen in industry, fertilizers, oil refineries, and steel. Okay, in the short run, but in industry, steel and transport in the long run. Long run, we have to go for the hydrogen only, and in short term, we should adopt immediately with fertilizers and refineries. But in steel, in long run, it will be 100% used. Okay. Yes. So now, that is not much important. What are the state policies? The national hydrogen mission is launched by the government of India. Site strategic intervention in green hydrogen transition. Also, they are giving the subsidies in electrolyzer installation as well as in green hydrogen per kg and per kilowatt capacity wise. So, individual state also initiated many provisions, many incentives for all those who are installing the electrolyzer plant or producing the green hydrogen. For Odisha, I just showing a slide. Reimbursement of rupees 3 per unit of power purchased and consumed from local. If you are from DISCOM, if you are purchasing any power for green hydrogen, you will get reimbursement of rupees 3 per unit, means almost you can say free. Okay, if it is purchased from the DISCOM for 20 years. Renewable energy consumed for manufacturing of green hydrogen and green ammonia. Cross subsidy for that cross subsidy surcharge, additional surcharge, and state transmissions will be exempt of 20. Any green hydrogen plant, if green ammonia, if using renewable energy only, then cross subsidy surcharge, additional surcharge, state transmission charge, all will be exempted for 20 years. Same 100% exemption from payment of electricity duty for 20 years. Will be no electricity duty for the power purchase from the grid. 100% exemption from the stamp duty. No stamp duty will be there. Reimbursement 100% GST, state GST paid, or are limited to 200% of the cost of the plant. How much? Up to the 200% of the cost of the plant and machinery. Reimbursement of 100% of the employer, even employer contribution in the PF or ESI and EPF scheme for the employers, that is also exempted for the 7 years. Okay, we can see the comparison incentive. You can see this sheet: Tamil Nadu, Gujarat, Odisha, Rajasthan, Karnataka, Maharashtra, like subsidized land, all are giving yes, almost. Some are in RE zone, some are in park. Okay, like in Gujarat, it is a subsidized land in RE park. Tamil Nadu, in industrial estates in SEZ. Maharashtra, RE and industrial zones. Same capital subsidies is also there. All are not given, but some are under discussion. Some are already, Rajasthan is already providing. Gujarat 25 to 30% capital subsidy on green hydrogen production. Electricity exemption, almost all state. Stamp duty and registration fee, almost all. Tax exemption, almost all. Export incentives, yes. Logistic and port handling facilities, yes. Karnataka, Rajasthan not applicable. Wherever the port are there, where you, if any producer green hydrogen want to export the hydrogen, this facilities like Gujarat, yes, logistic and port handling, some incentives is there in port. Okay, infrastructure support, almost yes. Single window clearance, almost all states. Single window clearance is given. Nodal agency, what are the state nodal agency helping? Yeah, I was discussing the strategic intervention for green hydrogen transition. Site क्या? What is the site? Strategic intervention for green hydrogen transition. What is this? It is just a capital. You can say CFA. Okay, मतलब financial incentive. The total site outlay under the mission will be 2000 till 2019 30 29 30. It will be 17,490 crore will be given to the for the electrolyzer and for the green hydrogen production or electrolyzer. Okay, for that they are giving even green ammonia also. So in electrolyzer manufacturing, you can say incentive for electrolyzer production in terms of rupees per kilowatt. Some rupees are fixed. It is already given by the government. Okay, per kilowatt capacity. What kilowatt capacity electrolyzer you are installing, accordingly you will get this incentive. Proposed for initial 5 years starting at rupees 4,450 per kilowatt. Okay, which taper down annually. Means for 5 years initially they are providing incentive 4,450 per kilowatt you are getting the incentive. If you are, for example, you are installing 10 kilowatt, you will get 400 rupees as an incentive. Proposed outlet 4,440 crore for electrolyzer basically. Same in green hydrogen production, incentive on green hydrogen production in terms of per kg, rupees per kg. That is what is proposed for 3 years. For electrolyzer it is 5 years, it is for 3 years and given 50 rupees per kg. Okay, 50 rupees per kg as an incentive. Proposed outlay 13,050 crore. Total 17,490 crore is the incentive to be given under the site, means strategic intervention for green hydrogen transition, a scheme of government in India to promote the green hydrogen and green ammonia production. Yes, simply procurement of equipments. What equipments we require, like electrolyzer we require, ammonia synthesis for green ammonia. If we discuss about green ammonia, green hydrogen we need to electrolyzer. Once green hydrogen there, we need the ammonia synthesis unit. Compressors also required. We need to compress to store it. Okay, at lower temperature and pressure. Storage tanks we require insulated for ammonia to avoid the corrosion. RE system supplier means if we go for solar and wind, ultimately we have to contact with the EPC contractor or OEM who are supplying like solar or wind plant. For chemical processing plants, for this storage, all this and handling, what that one we need to go with them. Industrial gas production. L&T is a EPC company like Thermax chemical processing plant for green ammonia, Siemens Energy, RE technology for electrolyzer, KBR Plus, Odisha green ammonia. These are the companies basically. Okay, what they are selling. Kirloskar is for pumps and just example I have given. Godrej is pressure vessel, storage tank, Inox air products, industrial gas products, solution and industry equipments. Okay. This is the transportation cost summary of green ammonia transport in Indian rupees per ton per kilometer. This is a comparative sheet per ton per kilometer. Okay, like if you want to transport green ammonia in pipeline, okay, through pipeline, what should again these pipeline should be insulated. The typical cost per ton per kilometer 2.58 to 5.16 rupees. Okay, if we go with pipeline, very low cost after infrastructure. If infrastructure is there, means pipeline is laid, then the cost is lower. This is the lower cost basically. If we are shipping, the cost is very high, 2,500, 1,736. Long distance suitable for international transport. Okay, rail 5.16 at 25.79. Land based transport limited flexibility because you cannot get land everywhere. Truck flexible for short distance. For short distances, but costly. 15.47 rupees per ton per kilometer. 251. It goes up to that one. Okay. Same. Yeah. I just telling you what is the difference. Different type of technology in the electrolyzer. Alkaline electrolyzer, that is called AEL. PEM electrolyzer, proton exchange membrane, PEM, and then other is the solid oxide electrolyzer, SOE, and last one is AEM electrolyzer. Okay. So AEL or AEM, you just technology type, alkaline technology, very cheap, सबसे सस्ती यही है. PM proton exchange membrane. Okay, this is you just the hydrogen production rate, low to medium for alkaline, medium to high PEM. PEM is better technology than alkaline. Okay, and solid oxide high. AEM low to medium. Energy efficiency 60 to 70% for alkaline technology. For PEM technology, it comes around 55 to 65%. And solid oxide 70 to 80, high efficiencies, but they are costly. Okay. Now, if we see the capital cost, alkaline technology comes per kilowatt $500 to $1,000. Okay. PM 1,000, 2,000, 2,000, 5,000 solid means SOE, solid oxide analyzer are costly. Okay. Same pressure range you can see, durability, lifetime, typical application, startup time. Startup time is important. Slow. Alkaline electrolyzer is slow race, minutes to hours it takes. Fast. PM electrolyzer is fast. So right now this is technology used basically. And if we go with lower cost, then we go with alkaline technology. Water purity requirement, low purity water required. For alkaline, very low purity means otherwise you have to go with DM water. Like if you are going with PM electrolyzer, in alkaline also we need to go with DM water itself. Okay, demineralized means water we need to pure. Whatever the water we are taking from the sea, coastal areas, we need to first filter it. Okay, demineralize it. Then we have to put in the electrolyzer plant. High purity PM is the high purity water required. PM. Same solid oxide electrolyzer also required high purity water. Maintenance is low to medium for alkaline, medium to high PM, and very high. Solid oxide electrolyzer required high maintenance. AEM also low to medium. This is the hydrogen safety. Safe issues can be okay. Break the simple assumption. What assumption for hydrogen? Today only I think a lot of people will come to know what is this hydrogen itself. Okay, so assumption, we already know how to use hydrogen. Some people say, yeah, we know hydrogen how to means how to handle, but it is not so. Hydrogen, like an other flammable, it is also some other gas. Misconception, hydrogen too dangerous, hydrogen बहुत खतरनाक है, ऐसा डर भी है. So these are the misconception, you can say assumption. But कुछ आधे ट्रूथ क्या है? हाइड्रोजन सेफ एज इट डिस्पर्स वेरी क्विकली, डिस्पर्सेस वेरी क्विकली. ये सेफ इसलिए कि फटाफट डिस्पर्स हो जाती है. रिवर्स जूल थॉमसन इफेक्ट हीट द लीकिंग गैस प्रेजेंटली. इनफ टू सेल इग्नाइट. ऑटो इग्निशन भी हो सकता है हाइड्रोजन का, मतलब ऐसा भी है इसका. सम हाफ ट्रूथ. इफेक्ट ऑफ प्रॉपर्टीज ऑफ हाइड्रोजन, हाई डिस्पर्सन रेट, डिस्पर्सेस क्विकली, मतलब बहुत जल्दी फैलती है. ठीक है ना, अगर ये लीकेज हो ना तो बहुत फास्ट फैलती है. ध्यान रखना. तो अवॉइड कन्फाइंड स्पेस. कन्फाइंड स्पेस में ऐसा नहीं होना चाहिए. कन्फाइंड एरिया हैव द रिस्क ऑफ एक्सप्लोजन होने का चांस रहता है. इन ओपन एरिया में ये होना चाहिए क्योंकि ये बहुत फैलती फास्ट है. हाई ब्यूएंसी यानी ड्यू टू लो मोलिकुलर वेट इट इज 14 टाइम्स लाइटर देन. हवा से ये 14 गुना हल्की है. हवा से 14 गुना हल्की है. कौन? दिस हाइड्रोजन. High buoyancy, due to low molecular weight, it's 14 times lighter than air. Adequate ventilation is must, otherwise pockets will be formed. Okay. Same toxicity and corrosive properties. Non-toxic, non-corrosive. Non-toxic होती है, जबकि green ammonia is toxic, but it is non-toxic. Okay, hydrogen. Due to high buoyancy, the risk of एसिफिकेशन इज रेयर. मतलब मीन्स जो अब आपने टॉक्सिक नहीं है तो अपने सांसों में दिक्कत नहीं आएगी. अपना रेसिप्रायरेशन सिस्टम प्रॉब्लम इसमें हाइड्रोजन के केस में नहीं करेगा, बट ग्रीन अमोनिया के केस में करेगा क्योंकि वो टॉक्सिक है. ओके, बेटर लीक डिटेक्शन, यानी मैक्स लाउडर नॉइज इन इवन स्मॉल, छोटा सा लीक होगा तो बहुत जबरदस्त आवाज आएगी, तो बेटर लीक डिटेक्शन फास्ट. ओके, डिटेक्टर्स विल बी प्लेस्ड आफ्टर डिस्पर्सन एनालिसिस. वेरी लो इग्निशन एनर्जी मीन्स बहुत फास्ट इग्नाइट हो जाती है हाइड्रोजन, तो मतलब आप लोगों को फ्लेमेबल टाइप के उस जगह में तो रखना ही चाहिए, जैसे माचिस वगैरह जैसे पास में लेके कोई हाइड्रो सिलेंडर, वो जैसे नॉर्मल सिलेंडर अपने घर पे एलपीजी वगैरह यूज ले रहे हैं उसमें अपन करते हैं, बट इस केस में थोड़ा वी हैव टू बी केयरफुल. एस टू एज ए वेरी लो इग्निशन एनर्जी, यानी 30 टाइम्स लेसर देन मेथेन. मेथेन जो गैस है CH3 OH जिसे बोलते हैं, CH3, तो उससे 30 टाइम्स लेसर है. तो अब यू कैन अंडरस्टैंड कितना फास्ट इग्निशन इसका होता है. तो लो इग्निशन एनर्जी है. इफेक्टिव इंस्टॉलेशन है, मेंटेनेंस ऑफ इलेक्ट्रिकल इक्विपमेंट एंड वायरिंग एज पर हैजार्डस एरिया क्लासिफिकेशन के हिसाब से करना पड़ेगा, क्योंकि किसी टाइप का शॉर्ट सर्किट हुआ तो इमीडिएट इग्निशन हो सकता है. वाइड रेंज ऑफ फ्लेमेबिलिटी एंड हाई फ्लेम स्पीड. इन लो इग्निशन एनर्जी ज्यादा एनर्जी की जरूरत नहीं है. वाइड रेंज मीन्स ए वेरी हाई प्रोबेबिलिटी ऑफ फायर इन केस ऑफ ए लीक रिजल्ट इनटू डिटोनेशन, मतलब आग लगने की संभावना इसमें ज्यादा है. मेटल कंपेटिबिलिटी ऑफ हाइड्रोजन, एम्ब्रिटलमेंट, हाई टेम्परेचर हाइड्रोजन अटैक STHA, यूज ऑफ मेटल एज पर एप्लीकल नेशनल और इंटरनेशनल स्टैंडर्ड. थैंक यू. तो ये नाउ इट इज कंप्लीटेड. You can ask question, or I will share this one means a feedback form. Okay, 1 minute. I just stop this one. Yeah. So how was the overall? What is your feedback? Hello, Mr. Narayan Pillai and Ravi Kumar Singh and Kishore Narayan Pillai raised hand. Narayan, Mr. Kishore Narayan. Yes, tell me. Hello, I am audible.
Yes, sir, you are audible. You are audible.
तो भाई बताओ यार, कोई एनी मतलब क्वेश्चन इज देयर?
No,
एक्चुअली
sir,
इट इज
this
ए
is a
न्यू,
useful session actually. Yeah, yeah, yeah. It is
इट
a
इज ए वेरी न्यू
new
सब्जेक्ट,
subject
इट
to
इज
us.
वेरी न्यू सब्जेक्ट. या सो इफ आई पुट द क्विज राइट नाउ अगेन, आई थिंक यू विल गेट 10 out of 10 maybe. Should I do? Can you take this quiz again?
Yeah, we can, sir. No problem.
Okay, now you take this quiz again. Should I share the link here again? I share. You have this in chat box.
Yes, sir.
Link is
It
there.
is one second. One second.
Submit,
I'm just checking.
submit another response so that you will come to know now the score is how the score is. But okay, you just take it again, okay, and tell me what is the score right now. Ravi Kumar Singh.
So the link is not presented in the chat box. Is it possible to paste one more time?
1 minute, wait. I just put it again. Yeah. Again, I put on in chat box.
Yeah, it is received. One second.
All do it and tell me now what is your score. Everyone has to participate. Two-person join now. I think they have not attended. Anyone got any okay, after completing this quiz, you can ask. Okay. Good. Yeah, Akshay Rathore earlier was 3 out of 10, or now 9 out of 10. Good. So which question is wrong? You can check or not.
प्राइमरी प्रोसेस वाला रॉन्ग हो गया सर, वहां मैंने इलेक्ट्रोलिसिस किया। नहीं,
क्या था? प्राइमरी प्रोसेस। अच्छा, इसमें ग्रीन हाइड्रोजन में।
हैबर बॉश प्रोसेस कर दिया।
अच्छा, उसमें तो इलेक्ट्रोलाइसिस होता है ना ग्रीन हाइड्रोजन में।
हाँ, वो जो अमोनिया है उसमें आएगा वो।
हाँ, अमोनिया में आता है वो। वही तो कंफ्यूजन वाला बात है ना। करेक्ट। सचिन
अभी
कुमार
मतलब
7।
फर्स्ट टाइम आइडिया है ना
अच्छा,
सर।
10 out of 10। गुड यार भाई सचिन, वेरी गुड। यू गॉट 10 out of 10। नाइस। ओके, so I will put this in group also, na? So that who have not joined, they will also tell me what they got. Okay, so whoever on doing right now, Kishore, are you doing? So should we close it?
यस सर।
Okay.
Yes, sir.
Okay.
I have only one doubt. Can I ask the question, sir?
Yes. Tell me.
Yeah, for the green hydrogen project, you have said that Tamil Nadu, Karnataka, and Gujarat have a more visibility to do this hydrogen process, right? Is
Yes.
it applicable for seawater also? Otherwise, we need to use our normal water,
No,
like
no,
a drinking water,
sea
like
water only. We will use sea water
okay.
only because huge water required. Na? For 1 kg, 9 kg water required. So
Right. That's why I'm asking this
sea
question, sir. Yeah.
that will be filtered. And then will be used for
Hmm.
electrolyzer. Means the all electrolyzer plant will be nearby the that one only. Either through
Sea
open
only.
access they have to water
Right.
required. Na? Water availability is that's why the
Yes.
India is best for green hydrogen. Green hydrogen hub.
Right,
Green
sir.
hydrogen
Okay.
hub will be the India because there is a huge water available. Okay.
Okay, sir. Okay.
Yeah.
Sir, my quiz point is 9 out of 10. Previously, it is 6 out of 10.
Good. Okay. 9. That's good. Ultimately, some knowledge received, na? What
Yes,
is
sir.
the
Yes.
hydrogen? What is green ammonia? What is the renewable energy role in this particular journey? What government
Yeah.
incentives? Everything, na? So you may come
Right,
to
sir.
know about this one also because right now it is not going so what. Actually, this industry is different, but ultimately you have to means doing that project which will be used for green hydrogen, for electrolysis. You will come
Right.
to know very
Right, sir.
soon. I am working for that wind or solar plant, which will give power to the green hydrogen plant, a green ammonia plant. You will tell in coming time. Okay.
Sure, sir.
Right now
Sure.
it is a
No issue.
prototype
Sir,
style.
we will get the PPT also in the share folders, right, sir?
Yes, yes, I will provide that. No issue. Okay. I will provide.
Okay, sir. Okay. Thank you. Thank you, sir. Thank you for your time.
Okay,
Thank you.
bye. Have a nice day. Thanks to join this webinar, and I will share this feedback form in the group, WhatsApp group. Okay. Thank you.